Here are problems 5, 6, and 7 on the kinematics review. Number 5, a college sprinter accelerates from rest, so V naught is 0 meters per second at 5.8 meters per second squared. So that's an acceleration, 5.8 meters per second squared. I'm going to put next to A. To his maximum speed of 10.2 meters per second. How long does it take the sprinter to reach the maximum speed? So we're looking for a time. I want to pick the equation without d in it, so that'd be Vf equals V naught plus At, and I'm solving for time. So I'm going to move the V naught term over to the left by subtracting it, which is why I have Vf minus V naught, and then I divide my A away. That's why it's in the denominator, and I plug my numbers in. 10.2 meters per second minus 0, all over 5.8 meters per second squared, gives me a time of 1.76 seconds. Number 6, a hockey player skating at 20 meters per second, so that's the initial speed right here, comes to a complete stop in exactly 1.8 meters. That's a distance. What is the acceleration of the hockey player, and how long did it take him to come to a stop, assuming his acceleration was uniform? Well, since he was stopping, that means his final speed is going to be 0. We're looking for both acceleration and time. Important thing to note, we cannot find them both at the same time, so you do not want to pick an equation that has A and T in it. If it's got both of them right off the bat, we're going to have two unknowns and we can't solve. So pick for which one you want to solve first. It does not matter. In this particular example, I solve for A first, so I pick the equation that does not have T, because if I have T and A in the exact same equation, and I don't know either one, I can't solve. So the equation that does not have time in it is Vf squared equals V naught squared plus 2AD. I'm solving for A, so I'm going to move V naught squared over first, giving me Vf squared minus V naught squared, and now I'm dividing the 2 and the D over to the left. That's why they're in the denominator. I can plug in my numbers. 0 squared minus 20 meters per second squared, all over 2 times 1.8. I plug in my numbers, and I get negative 111.1 meters per second squared. That negative is very important because you were moving in the positive direction and you came to a stop. So you had a positive velocity. To slow down, you have to have a negative acceleration. Now we're going to solve for time. I pick the equation without acceleration in it. So I use d equals 1/2 Vf plus V naught multiplied by t. I'm solving for t, so I'm going to have to get rid of the 1/2, the Vf and the V naught. So what I'm going to do is I'm going to divide by 1/2 or multiply by 2. It's the same thing, which is why there's a 2 in the numerator over here on the left side. And then I have to divide by the stuff in the parentheses, which is why Vf and V naught are in the bottom here. They don't need parentheses anymore when there's nothing being multiplied by them. So it's okay if you don't have to have the parentheses in the bottom. I can plug my numbers in. I have 2 times 1.8 meters, all over 0 plus 20. And that tells me it takes him 0.18 seconds to stop. And finally, number 7, a bullet accelerates at 6.8 times 10 to the 4th meters per second squared. It starts from rest, because before you pull the trigger on a gun, the bullet's not moving, so the initial speed is 0. And it travels 0.8 meters through the barrel of the gun. So that's our distance that it's going while inside the gun. And the question is, how long was the bullet in the barrel? So we want time. And with what velocity does it have when it leaves the barrel of the gun? Or how fast is it going when it leaves the gun? So the first thing I'm going to do, it asks for time first, so that's what I'm going to solve for. Well, I picked the equation that does not have Vf in it, because Vf is the other thing I don't know, and that's going to be d equals V naught t plus 1/2 At squared. If you just try and solve for time right away, it's going to be very difficult because it's in 2 different spots, and one of them is squared. It's actually a quadratic, so you have to use the quadratic formula. But if you take a look, V naught is 0. Because V naught is 0, that 0 times t is just going to be 0. That's why this term is crossed out, leaving me with d equals 1/2 At squared, which is a much easier equation to deal with. I have to get rid of the 1/2 by multiplying by 2. That's why you see a 2 over here in the numerator in the next step. And we have to get rid of the a, so I'm going to divide that, which is why it's in the denominator. And I don't want it squared, so I take the square root. So that's why I have square root of 2d over a. Plugging in my numbers, square root of 2 times 0.8 meters divided by 6.8 times 10 to the 4th meters per second squared gives me a time of 0.0048 seconds. That's really, really, really short, but that kind of makes sense because we're talking about how long a bullet stays in a gun. It's not going to be a large time. We're going to finish out with Vf. We're going to look for the equation that does not have time in it because that's the other unknown. And just in case we solved it incorrectly here, it's always a better idea, if you don't have to use something you solve for, to not. So I'm going to pick the equation without time in it. That's VF squared equals V naught squared plus 2AD. VF is already all by itself. I just have to get rid of the squared by taking the square root. So VF equals the square root of V naught squared plus 2AD. Plugging in my numbers. V naught is 2 times 6.8 times 10 to the 4th meters per second. Well, V naught was 0. So that's why this term goes away. I'm left with just 2 times 6.8 times 10 to the 4th meters per second squared times 0.8 meters. Plugging that into your calculator, you get a final speed of 329.85 meters per second.